Hi everyone, today I will introduce you to Konrad Zuse.
Now let's dive into the life of Konrad Zuse and learn about his birth and background. Konrad Zuse was born in Berlin, Germany on June 22, 1910. He is German civil engineering, pioneering computer scientist, inventor, and businessman who is considered the inventor and father of modern computers. Let's shift our focus to his educational pursuits. Zone studied architectural engineering at the Technical University of Berlin. His strong interest in mathematics and mechanical engineering soon steered his career in a different direction. Between 1928 and 1935, Zone accumulated valuable experience in engineering, laying the foundation for his future exploration of computers. Here are some of the milestones he achieved. Those designed and built the world's first electric programmable computer called the Z1. The Z1 was a mechanical switch-based computer capable of performing binary floating point operations. In the following years, Those brought an bigger breakthrough. He designed the Z3. It is considered the world's first actual electronic computer and an essential milestone in the history of computers. This used electronic magnetic relays to implement binary logic and operations, successfully perform calculations, and it's used to solve engineering and scientific problems. He also completed the Z4 after the war. In 1946, Zone founded Zose Engineering Bureau, which marked his first step in bringing computer science into the business world. Those developed a programming language called Blancaku, an early high-level computer programming language, in 1948. Let's talk more about this ray. This ray was built with 2,600 relays, implementing a 22-bit word long that operated at a clock frequency of about 5 to 10 Hz. The program code was stored on the punch film. Initial values were entered manually. This ray was proven to be Turing complete in principle in 1998. However, since it lacks conditional branches, this ray can only satisfy this definition by speculatively computing all possible calculation outcomes. Now we will look at those contribution to the technology field, focus on the computing principle of the Z3 computer he designed. Those Z3 computers adopt the binary system, a significant decision that transformed numerical representation into binary form, containing only zeros and ones. This innovation simplified the design and implementation of computer circuits. Secondly, Zones use a concept of logic gates to implement basic logic operations through electromagnetic relays. This includes AND gates, OR gates, and NOR gates, which lay the foundation for later computer design. Those also recognized the potential advantages of parallel computing early on through his work. He tried to perform multiple computing tasks to improve computing efficiency. However, Zones has faced technical challenges in parallel computing in its early days, including synchronization and communication. Although the technology at the time was limited, it inspired subsequent researchers. At the same time, those early focus on parallel computing influenced his views on computer architecture. His thinking provides the basis for concurrency and similar processing concepts in contemporary computer architecture. His ideas and experiments also laid the foundation for developing today's multi-core computer architecture. The contribution of his work to concurrency theory had a profound impact on the growth of computer science. Let's find the relationship between characters and computer architecture. Those has did a lot profound impact on computer science through the innovative design of electronic magnetic relays and binary system. Those made this the world's first electronic computer and provided pioneering idea for the hardware design of computer architecture. The design quickly became a model in computer architecture, laying the foundation for future computer hardware design. By introducing programming languages such as Plankaku, Zuse provides programmers with a high level of abstraction, which makes programming more flexible and opens up new directions for the evolution of computer architecture. His idea influenced the subsequent design of high-level programming language, make computer architecture more adaptable to changing application needs. We will find how Zone's idea came to embody contemporary computer architecture and continue impacting computer science. First, Zone paid attention and experimented with the concept of parallel computing in early years, which provided significant inspiration for implementing parallel processing and multi-core architecture in contemporary computer architecture. Parallel processing results from further evolution based on his ideas. Secondly, Zone's programming language ideas have promoted the continuous development of high-level programming languages. Today's programming languages are closer to human thinking regarding abstraction and readability. The abstraction allows programmers to focus more on problem solving rather than underlying hardware details, thus influencing the development direction of computer architecture. We are going to evaluate his profound impact on computer architecture. Zuse was not only a theorist but also a practical computer designer. His practical experience in hardware design, programming languages, and parallel processing provides a reasonable basis for his theoretical contributions. This unique contribution of practical experience with theory made his idea closer to practical application and directly impacted the development of computer architecture. Secondly, from the perspective of long-term impact, Zone's idea had an impact not only during his lifetime but also profoundly on computer architecture after his death. His idea became an essential node in the development of computer science, and the influence of his ideas on the contemporary computer architecture continues. Thanks for listening.